Hi friends. In this video I'll show you how to make a small power bank. It's lightweight, small and can be easily carried in a small purse or your pocket without any trouble. TP4056 charging module is used to make this charger. It comes with a mini USB port for charging input. C-port variant is also available. Wires can be attached to this terminals also. Remember, the maximum input voltage is 6 volt and maximum ampere is 1. Do not exceed this rating as the PCB may get damaged. There are two LED indication lights. Red light means charging is in progress. Blue light indicates battery is fully charged. It is perfect for charging single-cell 3.7 volt lithium-ion cells. There is a battery protection IC designed to protect lithium-ion or polymer battery from damage due to overcharge, overdischarge, and overcurrent. A dual power MOSFET is provided, which act as a battery disconnection switch. And a 4056 IC is used, which is a complete constant current, constant voltage linear charging IC for single-cell lithium-ion batteries. The charge voltage is fixed at 4.2 volts. These are the two terminals to which 3.7 volt power bank battery is to be connected. The output voltage is taken from these terminals. For this project I'm using a 3.7 volt lithium-ion battery. A female USB connector is used to take the output from the PCB, so the data cable can be connected for charging the phone. By holding the connector in this position, this is the negative terminal. And this is the positive. These are the data terminal, which is not required for our project. Next we need a DC to DC booster converter. This is the voltage adjusting knob. It can step up a 2 to 24 input voltage up to a 5 to 28 output voltage at up to 2 ampere. By adjusting the knob we can get a voltage of 5 to 28 volts from this output terminal. You will be surprised to see that I'm using cardboard to make this power bank. Please don't skip this video. By some simple steps I will show you how to make this cardboard stronger than plastic. By this method you can design any project easily, shape or finish it and last make it strong. You can see what I meant through this experiment. I have taken two cardboard strips of same dimensions. Using this super glue I'm going to paint one cardboard piece and see the result. I will compare the result with this piece. This is the test piece and I'm going to paint it with the superglue. Heat will be generated when the glue hardens. Within a few seconds it hardens and bounds the fibers in the cardboard. Coat the piece evenly and wait for it to dry. Now let's compare the strength of the two pieces. You can see that the normal cardboard piece bends and tear easily. With this property we can design it into any shape easily. After designing or molding it into any desired shape, paint the entire piece with superglue and make it stronger than plastic. You can see that I'm not able to bend the cardboard easily because the glue has bound the cardboard fibers. Thus, we can strengthen a cardboard piece by using just superglue. The next question is it waterproof? Let's soak the pieces in water and see the result. Even a small film of water makes the cardboard like a biscuit dipped in tea. Let's see if our test piece passed this test. You can see that the superglue acts as waterproof film over the cardboard and prevent water entering inside, even without losing its strength. Instead of heating and bending plastic to make a complex shape, we can use small pieces of cardboard and glue them to make the desired shape and make it strong and waterproof. By this way we can make any models according to our creativity. I prefer to use this method because it reduces the effort in cutting and bending material. Moreover, we can grind and finish the job quickly than other materials, thus getting a neat look. I'm making a simple rectangular outer box for the power bank. You can design any shape according to your creativity. When fixing the USB connector, try to make a small groove so that the USB fixing pins can be inserted. This prevents the USB from moving during frequent cable connection. Always make sure the USB port is easy to connect, because it will be difficult to remove after the cardboard pieces are fixed. I have made separate areas for the components so that wire connections can be made easy. I'm going to make a battery terminal junction, because soldering wires onto the battery terminals may damage the battery, and also it's not a good method. By using the copper pins from an old broken audio jack, I'm going to make the terminal connector. Without much effort, these pins can be easily removed. By gluing the copper pins onto cardboard piece, the connector can be made. Make sure the pins are touching the battery terminals. Confirm that there is good contact with the battery terminals. Now the wire connections can be made. Battery connections to this, and from the output terminal, the booster converter is connected and then to USB port. To save space, I removed the voltage regulator and connected like this. This is the wire connection diagram. I have connected all the wires according to the diagram. Since we are using a 3.7 volt battery, the output voltage from the PCB will be 3.7 volts also. It is not sufficient to charge a phone. That is, when the input voltage is given, the PCB will charge the connected battery by providing 4.2 volts. But when the input is disconnected, the output voltage from the PCB will be the battery voltage. By using the booster converter, we can step up the voltage to 5 volts. Rotate the voltage adjusting knob slowly to step up the voltage to around 5 volts. I'm going to make a charging indication window. By using an old pen refill, the window opening can be closed. After building the box, paint it with superglue completely to make it strong. I know it's not looking good, but after grinding and smoothing the sides, you can make it look better. Wait until you see the end result. Now you can see that the simple cardboard piece can be made strong and be shaped into your design. I am going to paint this with matte black paint. Now let's test the product. Using a 5-volt phone charger, charge the power bank. Red light shows battery is charging. It will take around 1.5 hours to charge the power bank fully. When fully charged, the red light turns blue. Coming to the end of the project, let's see whether we can charge a smartphone. This power bank can provide you with a backup charge in emergency situations. Instead of carrying a bulky power bank, this is easy to use and easy to store. When connected to the power bank, you can see that the phone is charging. So friends, I hope you have learned something new. And if you like this project, please like this video, also subscribe and support my channel for more videos. Thanks for watching and stay tuned for more videos. Bye.